We evaluate a radical function just like any other function. So suppose we let f of x be the fourth root of 2x minus 3. And I ask you, for example, what is f of 42? Well, you would say, everywhere I see an x, I'm going to write a 42. So this is the fourth root of 2 times 42 minus 3. So this is the fourth root of 84 minus 3. This is the fourth root of 81. And now, here's how we take an arbitrary root on the calculator. Right? Because if I just say square root, that's the square root. Right? That's the tooth root. And that's not what I want here. Instead, I'm going to go to the Math menu. And do you see this x root option? I'm going to choose that. I'm going to punch in a 4 for my root, and then I'm going to type in 81. And I get 3. So it just happens that the fourth root of 81 is a nice whole number, 3. Depending on your calculator, you may need to punch in the 4 before you go to the Math menu. If you punch in the 4 before you go to the Math menu, it will end up as the root. Depending on your calculator, you may see 4, a little x root symbol with an open parenthesis, and then you'll type in 81 and a close parenthesis. If this is what you see, make sure you see that this is the x root symbol. This is different than 4 square root 81. This is going to give you 4 times the square root of 81, which is not what you want here. So, on your calculator, experiment with punching this in until you get fourth root 81 equals 3. Alright, let's say we had a less nice number. Let's suppose we wanted to evaluate f of 7 and round our answer to the nearest thousandth. Well, f of 7, again, I'm just going to write a 7 everywhere that I see an x. So this is going to work out to the fourth root. 2 times 7 is 14 minus 3 is 11. Putting that into my calculator, 4 x root 11. I get some dreadful decimal, rounded to the nearest thousandth, 1.821. And if I still have my doubts about entering something like this on the calculator, I can check that. If I put in 1.821 to the fourth, this isn't exactly 11, but it's very, very close. Let's see one more example. Suppose we're asked to evaluate f of 1 over the real numbers. We would write f of 1 is the fourth root 2 times 1 minus 3, which is going to be the fourth root of negative 1. But at least if we're only concerned with the reals, negative 1 is not in the domain of the fourth root. So this is undefined. Alright, I'm going to have you try some of these. Let g of x be the fifth root of x plus 4. Evaluate each of these and round your answer to the nearest hundredth if needed. Pause the video and try this now. Alright, well, g of 1, that'll be the fifth root of 1 plus 4. That'll be the fifth root of 5. Fifth root of 5 is 1 point a bunch of stuff. I want to round to the nearest hundredth. 1.38. G of 5, that'll be the fifth root. 5 plus 4. So that's the fifth root of 9. Hey, 9's a perfect square. I wonder if that's going to be nice. No, it doesn't matter that 9 is a perfect square. To the nearest hundredth, that's about 1.55. G of 28, well, that's going to be the fifth root of 32. Hey, that's exactly 2. Is that true? 2 to the fifth is 32. So the fifth root of 32, exactly 2. And finally, G of negative 5. Fifth root negative 5 plus 4. That'll be fifth root negative 1. Uh-oh, negative number. Oh, that's okay, right? Because 5 is odd, so negative 1 is okay. What is the fifth root of negative 1? Maybe you already know it. Oh, it's just negative 1, right? Negative 1 to the fifth power gives me negative 1 back again. Fifth root of negative 1 is just negative 1.